the
Okay.
sheet, so I assume that it was taken care of.
Okay. Okay.
Yeah, it's other ones that we were worried about
Yeah.
with the X through it. So
Okay.
right through.
Cool. It's like some of these are running together, and some like there are competitor issues, and some there aren't competitor issues. I'm like, oh gosh, I don't remember which that was this one or. And Bill, how do you pronounce your last name?
Hoisington.
Hoisington.
Yep, Hoisington. That's fine. That's good.
Yeah. So pretty much what I'll do is once we launch live, like I said, I'll do some housekeeping things, and then do some some short bios, and then just hand them right off to you.
Okay. It did just say we're live streaming on YouTube.
It will be streaming on YouTube. Yes.
Okay.
Because that's how we then get it over to the website. Is it'll record it from YouTube, and then YouTube is connected to our website, and boom, boom.
Gotcha. Okay.
Yeah, lots of, it's like if we had Zoom, but Zoom doesn't have as strong of like connections. So then I'd have to like download the video and then re-upload it to the website. But it connects. Zoom will connect right to YouTube, and then the YouTube channel then just gets connected to our website. Or it's a whole back end thing that I only half understand.
Gotcha.
I just roll with it. Whatever Kellen, our operations manager director, says, I'm just like, all right, sounds good.
So do you see people starting to trickle in now, Nick, or this is not?
Let's see.
Live yet for people? Are they in the lobby waiting room or whatever?
Yeah. Let me actually check that. I should be able to start seeing some people. Not yet. So maybe I can't because we're not live. I'm not honestly 100% sure.
Okay.
That or nobody's 3 minutes early to a webinar anymore.
Yeah. I mean, I don't think I've ever been early. This is the only time I'm early to webinars.
Exactly.
Is when I'm doing it.
They usually sneak up on you. That's for sure. So.
Oh yeah. I think about that all the time when we do these webinars and like how we're trying to, make them more engaging and more things. And I always think about like, would I watch this? Like I try to always be like, okay, would I watch this webinar? And if it's a no, then I'm like, we might have to shift some things up. Like, not that I have a transportation background and I'm not really the target audience for this, but.
Nick, you saw my canned questions in time?
I did. I have them on my notes here. So, and I'll do the Q&A. So I'll throw the questions at you, so then you two don't have to worry about that. There is a Q&A panel that is on the bottom. So I don't know if you guys have seen that or not, but if there's any in there that you see that you're like, oh, I don't want to touch on this, like I know you can delete them. So I will moderate through the questions and ask them to y'all. But if you're in the Q&A chat and can see them and just like either I think you can exit them out or delete them. Like if maybe a competitor did sneak through and get in there and wants to ask like a question that you don't really want to touch on, feel free to go in and like exit out. Because I'm not really going to know. So I'm just going to ask it. And I don't want to put you guys in like a weird position of like, oh no, we don't want to touch on that.
Is that what so it says dismissed, answered is done, and dismissed, we've gotten rid of it. Okay.
Yeah, so it's open, and then there'll be a little button on the bottom that's like, answer live or dismiss or delete or something like that. So feel free just to,
Gotcha.
Okay. All right. It is 1 o'clock.
Let's go.
And then for both of you, you're welcome, obviously, to keep your cameras on the whole time. If you want to only have it on while you're presenting, that's great. I'm going to turn mine off after I'm done. But it's kind of up to you what you want to do. If you want to have it on while you're presenting and then turn it off while you're not, totally up to y'all.
Gotcha.
Okay. Let's start our webinar. Hey there, everybody. Thanks for joining our webinar today. Nice to see the numbers start trickling in. Supercharge Utility Asset Lifecycle Management with Esri ArcGIS integration. I'm Nick Frank, producer at Trimble. I'll be the moderator for today's webinar. But before I hand it off to our two incredible speakers, I do have a few housekeeping items that I need to attend to. Now, our webinar should take just about an hour today. That will include the Q&A portion at the end. To make sure we keep the flow of this webinar, all attendees are going to be on mute for the duration of the presentation, but you can submit your questions at any time in the Q&A panel, and our presenters will get to as many as possible at the end. Now, this webinar is being recorded. The video along with the slides will be available in the next 3 to 5 days. So, hey, if you want to send this to a colleague, feel free to do that once the slides and video have been sent out. We do have 2 poll questions during the presentation, so please partake when they come up, and stick around after the conclusion of the presentation for a post-webinar survey. We're always looking for ways to improve, and your feedback is the way we can do that. Now let's get to our speakers for today's presentation. First, we have Gregor Wilk. He's a solutions engineer at Trimble. He has nearly 10 years of experience with utility GIS and asset management systems, including a certification in asset management accredited by the Institute of Asset Management. In his current role as a solutions engineer, he helps utilities solve complex problems and modernize their workflow processes with Trimble Unity AMS and Trimble Vegetation Manager. Bill Hosington is a senior consultant and account manager for developing and implementing GIS and asset management systems at Power Engineers. With 25 years of experience working with utilities and municipal government, Bill has successfully deployed many Esri-based GIS and AMS systems. His extensive implementation experience includes project management, asset management planning, database design, requirement studies, application design, system configuration and training. Bill is a certified maintenance and reliability professional and holds a certificate as well in asset management from the Institute of Asset Management. And with that, I'll hand it off to Gregor and Bill.
Hey, thanks, Nick. So very excited today to get started on the webinar. We got a few slides we're going to go through and then dive into kind of a couple of demos of what we have prepared for today. First off, I want to start off and introduce you to an introduction to Power Engineers, the company I work for. Power was founded in 1976 by 2 electrical engineers in Idaho. Since then, we have grown quite a bit. We're now close to 4,000 employees with more than 40 offices located around the US and Canada. Power is divided into 6 major divisions, including business lines for energy, environmental, facilities, and technology. Our largest division, Power Delivery, focuses on providing a full line of engineering services, including distribution, transmission design, substation design, automation, advanced distribution management systems, energy storage, power testing, energization, and cybersecurity. I work in our Advanced Utility Solutions division, and we cover all aspects of GIS and asset management, including supporting the full ArcGIS enterprise platform, asset management and work management deployments, grid modernization, including ADMS deployments, and then also provide managed services for hosting and monitoring GIS-based applications. Next, I'm going to turn it over to Gregor to talk a little bit more about Trimble.
Thank you, Bill, and good morning, good afternoon, good evening, depending on where you're logging in from across the world today. Thank you for joining. A little bit about Trimble. Trimble was founded by Charlie Trimble back in 1978. So we're in our 45th year of business here at Trimble, and we started with pretty humble beginnings in the geospatial realm, creating and designing those GNSS and GPS receivers that a lot of people are familiar with today, and that Trimble is probably most ubiquitous for at this given stage. There are 4 verticals up here that Trimble serves, and these are some, but not all of the verticals that we serve solutions for, including transportation, where we do logistics and software solutions for trucking, rail, and other transportation industries. Construction we serve, and if anybody has gone or is familiar with the Trimble Dimensions Conference that's taking place in Las Vegas this year in November, that serves our construction market. Geospatial, again, with our plethora of GPS and GNSS receivers and devices that kind of brought us to our start and where we are today. And then what we'll be focusing on this webinar is utility asset lifecycle management, specifically targeting our Unity AMS software platform. And this is part of our owner and public sector. So this is targeting asset owners, utilities, and public infrastructure. So that's where we'll be focusing. The bulk of the content today is in that fourth utility asset lifecycle management sector.
Thanks, Gregor. So I want to talk a little bit of how we all fit together. So Trimble, Esri, and Power Engineers are all business partners working together to deploy public asset management. Power is Trimble's business partner focused on the energy industry to deploy CityWorks powered solutions for asset lifecycle management. As a partner, we provide system integrator services, including deployment services, identifying requirements, configuration, doing integrations, training, and go-live support. Other partners at Trimble provide complementary solutions and integrations for the platform. So let's talk a little bit about asset lifecycle management, what it is and how Trimble's defining it. We see three core components to ALM. The first is digital project delivery. Digital project delivery is the use of digital data to plan, design, construct, inspect, and record as-built conditions throughout a construction project. With DPD, owners coordinate with stakeholders and users and using reliable data to deliver projects on time and on budget. DPD handles the plan, design, and the build processes. With Trimble, we use their e-builder platform for this. Then enterprise asset management. Enterprise asset management is the ability to cost effectively plan, manage, and optimally maintain assets for maximum performance across the lifecycle. Unity AMS is a GIS-centric asset management solution that streamlines the maintenance activities by integrating office to field to office workflows, enabling teams to improve both operational efficiency and asset performance. EAM is used to track the O&M activities. And then the connected data environment. CDE provides the platform to share data between these systems. By centralizing data across asset lifecycle, CDE eliminates information gaps caused by legacy proprietary data formats or old file-based systems. This ensures data is updated in both systems and provides confidence to the stakeholders that use the data. CDE is the integration between the systems, and this is based upon FME workflows and services. Next, I think we have a poll question. Nick, can you throw up the poll? All right. So we just want to get a little insight on who's attending and why you're interested in this webinar. So first off is why are you interested in the webinar? Is it field mobile software, vegetation management, enterprise work management, inspection software? I don't know if we have any results coming in, Nick.
Oh, they're coming in.
They're coming in.
Just over 50% done. So maybe another 10, 20
right.
seconds here, and then we can share the results.
We'll give it a second. Okay, thank you. Really interested here to see what, why you joined and what you're interested in. All right. So it looks like about 21% interested in field software. Gregor is going to be doing a lot of demo of that. Few people, 13% interested in vegetation management. And we'll talk a little bit about those workflows. Enterprise work management is the bulk, and that's what we're focused on. And implementation, inspection software. All right, well, that's great. That seems to fit kind of the dynamic that we have. So next, let's move on to, all right, complicated utility workflows. The work that is occurring at utilities is getting more and more complex every year. Utilities are required to track more data, more details, track materials, and even track barcodes on different assets. Regulation is requiring more reporting, and the desire to use data analytics requires more information be collected. All of this in a mobile disconnected environment. Utilities have workers in the field requesting streamlined workflows and access to accurate, timely data. The complexity of the environment is fostering new tools that support responding to outages, customers' requests, and storm events, in addition to routine work. The complexity of this environment is one of the reasons Trimble is developing the Unity AMS powered by CityWorks solution. This new offering helps address these industry challenges. The new solution provides a GIS-centric application built and leveraging the CityWorks platform and ArcGIS technology. CityWorks has been the leader in asset management for over 25 years. This platform is devised for lifecycle asset management, including permitting, construction, O&M, and replacement activities. It provides a system of record for assets information and asset activities. Unity AMS expands CityWorks functionality by providing the Unity mobile software. This allows for a seamless connection of workflows from the office to the field. This allows field data collection of data that drives asset plans and investment decisions. Unity AMS provides functionality to address service requests, trouble calls, inspections, condition scoring, work management, including cost tracking for equipment, labor, materials, including compatible units, inventory control, PM scheduling, resource allocation, and workload management. Other functions include risk assessment that helps track the consequence of failure and the probability of failure to determine a business risk exposure rating. Project management functionality is available to manage large-scale investment projects and track associated costs, budgets, and contracts. So what does this platform look like? Starting at the bottom, Unity AMS is built on the ArcGIS Enterprise solution for the system of record for asset information. This allows for native GIS functionality to support asset attribute and location editing. Unity AMS uses map services and feature services to provide this functionality. This includes supporting the utility network datasets. Next, the CityWorks platform provides the AMS functionality. Unity AMS includes industry workflows for inspection, vegetation management, and O&M activities. The standard components of Unity AMS include Respond for your office workflows, Admin for doing configuration of the system, OpEx for projects and contracts, and Workload for scheduling. There are additional components that can be licensed for vegetation management, including LiDAR Analyzer, Storeroom for inventory control, Operational Insights for risk assessment, and the Esri AR Converter provides augmented reality using Trimble's Sight Vision platform. All of this is supported by a robust set of APIs for custom integrations and customizations. The mobile apps are support field operations using Windows, iOS, and Android software. All right. Unity AMS provides tools to manage any type of asset at any time from anywhere. This allows users to be connected in the field and in the office. They can share geospatial data across departments and organizations, allows users to engage with citizens and customers using geography, and can collaborate with contractors using location-based data. Unity AMS is a geospatial platform that supports the system of engagement for customer interaction, system of record for authoritative data, and a system of insight for geospatial and non-geospatial business intelligence and analytics. So let's dive into this a little bit deeper into what GIS-centric is. CityWorks is based off the idea of what if the Esri ArcGIS could be used as a system of record for infrastructure. What does this mean? Well, we use the GIS as the asset hierarchy and the asset repository. All asset data is stored in the GIS. In Unity AMS, we don't store duplicate asset data in the asset management or work management database. So this works using the GIS database and software for the asset data model and provides authoritative data of the assets. Since Unity AMS is tightly integrated with the GIS, it takes advantage of the GIS for any land-based data, the ability to create maps, and for geospatial analytics. The Unity AMS database is used for authoritative data to track any of your work order data, inspection data, condition and risk, costs, and scheduling. The two database system and tight integration with ArcGIS allows for no duplication, no data sync. It's bidirectional, and it's in real-time integration between the asset data and the O&M data. It also allows Unity AMS to support single sign-on using ArcGIS credentials and security. This approach also allows Unity AMS to support the new Esri utility network using feature services. Unity AMS is utility network ready and one of the first EAMs to support the utility network. So how does Unity AMS leverage the GIS-centric nature of the application? Well, this means location is very important to every activity. For service requests, this may include always tracking an address on a request or for an asset or the caller. For inspections, Unity AMS attaches the inspection to the asset in a one-to-one relationship. For work orders, Unity AMS can be attached to one asset or to multiple assets. Unity AMS includes templates for service requests for things like service disruption, emergency shutoff, vegetation management, streetlight outages. Inspection templates include asset identification, work history, and condition observations and scoring. This allows you to assign a weight to the observation and to the result. At the end of the inspection, a condition rating can be calculated based upon the observations. Inspection templates are included for poles, substations, and transformers. The work order templates include outage response, vegetation management, and O&M functions. The mobile functionality includes support for disconnected operations, including processing all of these requests, inspection, and work orders while offline, and referencing GIS assets and base maps offline. The software uses an auto-sync function to pull and push data back to the office from the field when a connection is available. Also, Trimble GPS devices are supported for tracking high accuracy location for requests, inspections, and work orders. Unity AMS is a cloud-first SaaS solution. We are seeing clients trend to using cloud-based solutions. They're looking at the cloud because the cloud has some advantages, things like it's accessible from anywhere, the field, the office, remote work locations. It's easy to access the platform and doesn't require any custom software or VPN. It's scalability. Easy to go from 10 to 100 users quickly. The cloud infrastructure provides more resources as the demand increases. Companies don't need to buy more servers to add users to the platform. It supports collaboration, easy to add users and shares data. Contractors and third parties can be provided access to the system to support their workflows. Security. The cloud security is managed by AWS and experts using modern security practices. It also modernizes workflow. So current software and browser-based applications connect with modern application interfaces. Mobile apps on mobile devices are used to do the work. Unity AMS Cloud is based upon the CityWorks online solution, is hosted by AWS. Even with all these benefits of the cloud, some utilities are not ready or willing to move to the cloud SaaS solution. Unity AMS can be deployed as an on-prem solution using the utility's IT infrastructure. So how are we seeing Unity AMS getting deployed? Power, as a system integrator of CityWorks platform for the past 25 years, has seen all types of approaches used for deploying this software, including enterprise deployments across all departments are deployed all at once, covering all workflows. This is the Big Bang approach. This usually creates a very large, complex, enterprise-wide project. Other clients have been successful deploying in a multi-year phased deployment, bringing on new departments or workflows every 6 months or so. Phases allow the project to be controlled and uses lessons learned from a previous deployment to improve future deployments. One trend, kind of the major trend we're seeing right now, is using a jumpstart approach to deploy the software quickly for a limited amount of workflows or users. This can be accomplished using the SaaS solution and the templates included in Unity AMS. Some clients use ArcGIS Online to simplify access to the GIS. Clients identify key workflows that can be improved using Unity AMS and deployed to solve a specific problem. We see a number of benefits using this approach, including it's a fast deployment, maybe up and running in 3 months, easy to adjust to the software. Small groups of users can be trained up quickly, and new users build confidence in the system early. All right, so that kind of includes my portion of the presentation. Next, we have another poll question I think Nick's going to throw up there, and then we're going to dive into some example workflows and a demonstration of the software by Gregor. All right, so poll number 2, what are you using for your work management tracking in the field? Are you still using paper, maybe Excel? ArcGIS provides a number of applications such as Survey 123, a field maps. Or do you have a work order management system? You know, CityWorks, Maximo, SAP. Just trying to get an insight of what's current our webinar participants are currently doing.
Yeah, results are coming in. We'll give another 15, 20 seconds, and then we'll share and see what everyone's working with.
Okay, great. Thanks, Nick, throwing that up there. And Gregor, you're on deck here in a second, so get ready to transfer this over to you. All right, so interesting to see, still about a quarter out there are using paper in the field. Excel is used a little bit. Survey 123, 12%, and then the majority are using an enterprise work management system. So that's great. Great to see there's a lot of potential, a lot of people benefiting from EAM, and there's a lot of growth potential for people using paper. Like to see that. All right. So Gregor, I'll turn it over to you.
Okay, well, thanks a lot, Bill, for the excellent background on the Trimble Unity AMS solution, as well as where Power Engineers fits into our Trimble partnership, being a preferred implementer of Trimble Unity AMS and a service provider for this product. So I'm going to give a brief outline here on the demonstration that I'm about to show. I think based on the first poll results, we'll be hitting the mark in terms of what a lot of you are interested in, and that's enterprise work management. We'll be showing some inspection workflows throughout. And although we will not be highlighting vegetation management in this particular webinar, the solution is more than capable of handling vegetation management workflows. So please, we'll follow up with those interested in VM after this webinar and show you how the product can manage those workflows. I believe about 10% of you were interested in vegetation management. So to give you an outline, we will be kind of doing a story-based demonstration where we have 2 different users. We have one would be more of an asset manager or operations manager role, and then we'll have a lineman go out in the field as a mobile worker and complete some inspections. And we're going to start by creating an asset risk-based assessment on transformers using our tools. Then we'll show you how the asset information in GIS information is pulled into the product, as well as developing that work history over time. We'll give you a tour of the mobile product and how that is used in the field, and then tie it all back together in the office, close out the workflows, and then show you how projects can be created, assigned, and budgets can be tracked against the work activities in the field. So next slide, please, Bill. Yeah, we are going to pivot to the demonstration now. So just give me a moment to share my screen. And I'm going to take you on a recorded demonstration of Trimble Unity AMS. I will pause it periodically throughout and narrate. But Bill, can I get a quick verbal confirmation that you can see my screen and the video I'm about to present?
Yes, we can see you. Looks good.
Perfect. Thank you. So I'm going to go ahead and get started. You'll see we're at the login splash screen here for Trimble Unity AMS. And if you're eagle-eyed, you'll see in the corner, the solution is powered by CityWorks. So you see that up in the upper left. Otherwise, you're logging in through the Trimble Unity AMS toggle button in the middle. And right away, you'll notice that we take advantage of solution capabilities for single sign-on using your Esri credentials. So we can use those to log into the software, or we can use a different IT login parameter like Okta or anything else that your organization has established for passing those credentials onto the software. And what we've done now is logged into an application, HTML5 web application called Operational Insights. You'll notice along the left side there is a toolbar for various functions within the software, and we'll be going through some of those features today to create that asset risk strategy. So Trimble Unity AMS is completely a GIS-centric web-based enterprise asset management platform. And we're starting our demonstration here today as the asset manager who's going to go ahead and create a GIS-based risk scenario for transformer inspections and replacements. So we're going to create work packages based on transformer condition and then GIS values that we've already collected out in the field. And to do that, the software is very intuitive. It lets us pick from a group of assets that we have configured within the system. We can search for our particular asset in question, which is transformer. And then we get to create a strategy that is going to use GIS attributes to assess the risk. And so when we look at the panel to the right, we can see that we've named the strategy. We can assign this a rating level of 1 through 5, 5 being the highest rating in that system. And then we can use the GIS attributes to make up these strategies. So we're looking at now probability of failure. So what GIS attributes do we collect in the field that are going to contribute to the likelihood that this asset is going to fail? And we can pick up from that list of attributes right here. It's giving us a drop down of every field that we're tracking against transformers. And then we can give this a rating method between a specific value or a range, and then assign it a weight of 1 through 5, again, 5 being the greatest. So in this particular instance, I have made this very simple, and I've taken a condition score from real inspections that we're doing in the field, and I'm assigning that a weight of 5. So it's my most impactful attribute score in this strategy. I'm saying the existing condition of the transformer is the strongest factor driving whether or not this will fail. And you can see, based on that condition score of 0 through 100, 100 being the best score in this case, that rating score is divided 5 through 1. And so if the transformer is in great condition, it gets a score of 1, and then it is not likely to fail in this strategy. The next attribute type that we'll be looking at is the construction type. So is this transformer overhead or underground? And obviously, if it's overhead, it's exposed to the elements, rusting, weathering, all kinds of things. It's going to be more likely to fail. Thus, we give it a score of 3. And then underground transformers get a score of 1. And if there are any null values in the GIS, you can give those a factor of 1 so that they do not contribute towards your score. Then we can also look at the consequence of failure. So how impactful would it be if this asset were to go out of service on your network? And who would that affect? So for this strategy, again, keeping it simple, we're going to say that the operating voltage of the transformer is going to be the most impactful if it were to go out. And then we can also use risk mitigation. So if you're doing anything to mitigate the risk, if you're proactively inspecting these assets, if you're doing any kind of rehabilitation work orders, those can all be factored into the strategy as well. But for this instance, we're going to go purely off of those risk factors for consequence of failure and probability of failure. Once those scores are settled on, and again, these can be as many or as few scores as you want. There's really no limit to the amount of GIS scores you're bringing into the strategy, as well as no bottom limit, as long as you have at least 1 in there. But the more data you have, the more robust score you're going to get, the more accurate your results are going to be. So keep that in mind. But you can use as much or as little of that data that you're tracking against the score. And then you can run the calculation. So this is us calculating the probability of failure, consequence of failure, risk mitigation, and business risk exposure scores based on that strategy we set up and created. So now you can see a table of the results, and it creates those scores against every transformer in the GIS. And we can parse through this, look at it. We can export it to a CSV, so we can look at that in Excel or Google Sheets, do what we want with it in an export. But within the software itself, we can actually visualize this in a dashboard. So the neat thing about this is we can look at that score in more detail by looking at these graphs and charts. So right out of the gate, I can see that my probability of failure for most of my assets is very unlikely. So that's really good. Most of my transformers are unlikely to fail, but you can see towards the right side of the curve there within the bar graph, I do have a small handful of assets that must be in poor condition that are likely to fail. But I do, on the other hand, have a lot of transformers that would have a high consequence if they were to go offline, probably again, based mostly around that kVA or operating voltage. And when you combine those two scores, you're getting your total business risk exposure. So what is the likelihood that asset will fail and how impactful will it be if it goes down? Combination of those two equals the BRE. And we only have one asset that's in that upper range. So again, that's a good thing for us to see as a utility. But using these scores to our advantage, we can create, again, that inspection or work management program around those. And what we're going to do here is I have opened up a map viewer because, great, we've seen these transformers in a list now. Let's actually take a look at these spatially and highlight that GIS-centric nature of the software. So now I'm going to select all the transformers that are in my upper range of probability of failure, because I want to take a look at these as the asset manager and just see where these are in my network. So I can open my map, do a split screen view, take a look at this, or go to a full map toggle and just take a closer look at where those transformers are that are most likely to fail. And you see I've highlighted all of those on the map. So we can see each location, zoom in a little further to go ahead and, maybe see any trends. These all look like they're sort of in one neighborhood. So maybe there's something going on in this particular area. Maybe they were all installed around the same time. Whatever that might be, it's just good to get that spatial insight into where those are taking place. And now we can actually make this data actionable. So we've created that strategy. We've highlighted the assets. Now let's do something about it, right? We know these are likely to fail. So let's create a package of inspections to send our linemen out there and go take a look at those transformers. So this right from the map allows us to create an inspection, submit it to the appropriate person, and then assign it a priority, in this case, high priority. And that gives us a list of all the inspections that were created that we could go into natively right there following the hyperlink. But we'll show you how to switch to the Respond application, which is our primary Office application for enterprise asset management, dashboarding, reporting, etc. So I have used the toolbar on the left, again, to navigate between my apps. And we're going to be moving to Respond just by clicking that in our app switcher. This will navigate me straight to the application without any applications or logging in or logging out. So you notice I didn't have to log out of the software, pass any credentials. It just takes me straight into the next HTML5 app. Here we have some of the industry out-of-the-box workflows that are included with the software. So we have, think of them as local government templates for repair, replace, maintain, and install work orders on some of those asset types that Bill listed. And this is one example dashboard around distribution management. So we're able to query GIS for all of our poles, wires, and transformers. We're able to keep KPIs about how many transformers we've inspected, take a look at the work that's taking place around those assets themselves, and then track the program cost on an overall basis. What are we spending on these assets as we perform work on them? And we can move this from an inbox to a split screen view, again, where we're looking at that same web map that we had of our electric distribution network. We can toggle that into a full screen view if we want to look at nothing but the map. The software allows you to easily toggle between the dashboard and the map view to take a look at what's going on within your network. But if we're to bring this back to kind of the dashboard view, we're going to go ahead and show you what it looks like to view those transformers, as well as their inspection results and the details behind them. So notice in my leftmost panel there, I've got my list of pole-mounted transformers, and I can sort this by various scores. So here is the condition score that we're calculating based on real-world inspection observations. And I can sort that by the descending score, meaning that I can now click on my transformer with the worst condition, and that was 42. And I want to take a look at that transformer and see what's going on with this particular asset. So I can click that, view the details, and read the GIS directly of all the GIS attributes that we're maintaining on this particular asset. So you'll see things like the operating voltage, the install date, and these were some of the fields we used to create that risk strategy. Scrolling up, you'll see here, if I stop it at the total cost, we're building a physical work history on every asset that we perform work on. So we are able to see the total cost and hours spent performing work on this asset as well. And in a summary view, we can see each work activity type that was prescribed to this transformer. And we can divide it even further by work orders or inspections specifically. So looking at the install of this transformer cost us $2,400. And now we have that open inspection to go back and take a look at this transformer because it is now in poor condition. So for each asset spatially, we're tracking a complete work history from cradle to grave across the asset life cycle. You see right from the asset details panel, I was also able to navigate to the open inspection that's on this asset. And here we're just taking a look at that in the office environment here. Over the web, this is what, again, the asset manager or operations manager type role might see in the office. But we know that that person's not going to go out and most likely inspect this asset. So what we want to do is transition now from here in the web platform to Trimble Unity AMS and Trimble Unity Mobile, which is the mobile application that supports the platform. Now, this is a native application that works on iOS, Android, and Windows devices. So really it should fit the multiple devices that your IT might be requiring that their users use, whether that's a work phone, a laptop, or some kind of tablet. So it works on across all those operating systems. And it can also go offline. So we have robust offline capabilities to take your field work when you need it, where you need it, without an internet or a Wi-Fi connection. And I'm going to take you on a brief tour of the mobile application where we're going to look at much of that same data we saw in the office, but within the mobile native app. This is on an iPad. And you can see I can have full control over my web map that I have assigned to this user, where we can toggle the layers off and on from a visibility standpoint. So I can clean up this map to just take a look at the layers that I'm interested in. And as a lineman, I'm mostly just interested in seeing those poles, the transformers, and the overhead conducting wires. So I'm going to make sure that those assets are visible and selectable, and then toggle the rest off to clean up the web map that I'm looking at. So once that's complete, you'll see that I have a much cleaner mapping interface. I can also see blue pins where every inspection that I have is pinned to, so I know the XY location of every asset that I have to go out and inspect. And then we can toggle this base map on at any point if we lose internet connection, or we know we're going out into a rural location where we need to continue to use this map and work on our assets, even though we're offline. So Trimble Unity Mobile supports tile package maps for this instance. We can download that directly to the device. And in the future, we're looking at supporting MMPKs. So if we need to, we can select that base map, or we can continue to use the web map if we have a good internet connection while we're out in the field. And now across the top, we'll get into the inbox where we have our activities sorted by work orders, inspections, and service requests. And you can see that color change go across the top of the iPad while I'm navigating between those, just to help you orient yourself. And we can sort our list of inspections by various fields. So we could sort it by the priority, which I've done here. We could sort it by the start date or the due date. So you have various parameters to sort those inspections and get to the one that you need to, as well as just search that ID number if you have that handy. But what I'm going to do now as lineman is find that high priority transformer inspection that was just assigned to me from my boss in the office. And the first thing you might want to do is get driving directions out to the job site. So this will integrate natively with Google Maps or Apple Maps, whichever is installed on your device. It'll bring that up and then help you assign, the best route to that given location and get you there free and clear. And once we've arrived at the job site, we also have locate tools to help us get there even further. So now that we've driven ourselves out to the location, we've routed ourselves maybe to the nearest intersection or where we can park that truck. but we might also need to find walking directions essentially to that given asset. So here on the bottom left, you'll see there's a compass and bearing tool that flashes our given location and our azimuth to that asset. So in blue is the direction I'm facing, and that dot is the asset I'm trying to navigate to. So as I turn my device, it's showing me my direction from that location. If I turn around, you're going to see the azimuth change. And this, you can use your device GPS, or you can use a Trimble piece of hardware or GNSS receiver to get a more precise location than the device satellites would give you. Once we've located the physical asset in question, the transformer, we're going to go out and inspect it. So this is the inspection form that we saw in the office. It's just a more easy to use, intuitive interface that is field friendly. And we're going to go through the parameters of the inspection so we can capture the location, which is already coming from the GIS, but if needed, you can update the XY while you're out in the field with the Trimble receiver or the device. And then we can actually get into more of the inspection details. So we have the transformer as a GIS feature is attached. And then look at the observations. So this is the bulk of the inspection, is what questions am I answering about this asset in the field? And again, Trimble Unity AMS comes with some very industry-specific templates out of the box. This is something you would receive as part of that Jumpstart implementations with Power Engineers. But if needed, any inspection can be catered to an individual business process. So for a transformer, we're just going to collect a few basic fields. And one of the more important ones is the oil level. So is the transformer leaking anything? And notice when I hit a specific observation answer, we support conditional observations that follow that. So when I hit the low answer for oil level, a new question has popped up beneath that asking me if the transformer is leaking oil. So that's an example of a conditional observation. And notice that will go away if I change the oil level answer to good or something else. But if it's low or critically low, that subsequent answer follows in the series. So we can support those, and then we work through the rest of the observations as you would note them in the field, including calendar widgets for any time a time or date stamp is asked for. And then we can attach, very important to attach photos or video of the assets. Here's my transformer, what that looks like in the field. And I've taken a picture, attached that directly to the inspection. And I can also sign off on that if needed, as well as the inspector. I can sign my name and capture a digital signature. Next, we'll add some labor costs to this inspection and just track the employee's time that was spent out there. These can be variable costs, hourly costs if it's staff, or it can be fixed cost if it would be a contractor that's doing this. And we can get that time logged to the inspection. So again, we build that cost and asset history information. Now we can finally update the status of this transformer. We can go from this inspection being open to completed. And then you'll notice that my application tells me to sync because we've made some changes to the data that's now available. Now, at this point in time, we're going to go down the scenario that this lineman has inspected the transformer, but while they're out in the field, they've noticed just down the road from them that a pole has some damage to it. Maybe it's a bent or loose crossarm that's hanging on the pole, or itself is leaning or has some other type of damage to it. And what we want to do is show you the capability of creating unplanned maintenance work order while we're out in the field. So not only can you log the issues that are important to you from the office, you can also create work orders while you're out in the field, thus eliminating data silos within the organization. So if there was a tree damage or a limb across the street, we don't have to log into another system to take care of that. We can actually log that as an issue within Unity AMS and dispatch that to the proper crew. Now, what I've done is I've selected the pole. I'm just showing you that you can look at the GIS details in the mobile application as well. So we can get the pole ID and learn more about this structure. Data in our fingertips in the field is really what that is. And then we can create the work order ad hoc in the field. And we're going to go ahead and say that this pole needs to be replaced, and then assign that to the proper priority and the crew or the supervisor that's going to be responsible for this work. So once I've given it to my supervisor, I'll just show you the process of filling out this work order as if I were the crew member out in the field. And much of this is similar to the inspection, but we have some additional fields on work orders. that we'll be highlighting shortly, but I'm going to quickly put in a comment about why we've created this work order out in the field, because that wasn't originated in the office. Again, here's the pole that's attached. Our GIS coordinates there for X, Y have been attached. And then we have work order tasks, which is simply a easy way to subdivide the job into its component parts. So if we've got a pole replacement, we can divide that into, for instance, the traffic and safety setup is a necessary component of that. We have to remove the existing pole, and we can track the start and stop times of each of these pieces of the job through the task module. And then we can create custom response codes. So if we have any particular issues in completing this answer, for instance, if I say I can't excavate this pole for any reason, we can fill out that response code and then query the system and leave a comment as to why this work order is currently on pause or needs to be revisited. But we'll just go through here and finish the rest of the tasks, including installing the pole. When did we install the pole? There's that calendar widget again. Install the guy wires and the anchors to make sure this pole is secure. And then maybe we got to clean up the site, repair some lawns if we got anything ripped up, shovel the dirt off the road, sweep it up, that kind of thing. So now that all the tasks are complete, we'll move on to closing those out and making sure that they have proper time and dates synced up with them. And then we'll move on to the rest of the work order here, which is going to be adding, again, attachments. So this time we could take a live photograph. So that's just taking a photograph of something we saw out in the field, attaching that to the work order. And then we'll do another gallery photo this time. Maybe that's the pole before we replaced it. And then a handy feature here is the map capture. So this will center me on my map location where I'm currently located, gives me some basic paint tools so I can mark up the map, maybe write a comment and highlight an area, and then save that screen share directly to the application and the work order itself. So we got a digital record of all those three things. And then we can go ahead and add our equipment, labor, and material costs through a crew-based entry form. So what the crew-based entry form does is it really just streamlines the data input process. It pairs people who typically work together very closely on a day-to-day basis and allows you just to select the equipment and material that you used for that given day, as well as how many units and how many hours you may have taken that truck out in the field, and then add any consumables in the process. And these could pull from a stockyard or a warehouse, and we have an inventory module to support that, those quantities in the field as well. Now we've got pretty much everything we need added to this work order. I'm just going to review that I have the right pole attached. You can view that on the map if you'd like, or we can just go ahead and basically complete this work order out, send it back to my boss saying that we're done with this, and let's move on to finish the workflow. Now we've done all these stages directly from the field. So now what I want to show is that sync process where we now have an internet connection, maybe back in the office or still out in the field, and we're pushing those live updates from the field back to the office. So it gives you a sync bar to measure that progress. And then all my boss would have to do in the office is refresh a dashboard, hit the refresh button on his browser, and then we can see those updates within the Respond application back in the office. Now, astute observers will see that before I had nothing in my completed boxes, but now I have that completed transformer inspection. And as the asset manager or supervisor, it would be my job to go back in here and review my lineman's work, make sure they've completed the inspection as they should have, attached the proper photographs, answered everything as they should, and then close it out if everything looks good. So we can now move that inspection to a closed status. That will fall out of my inbox in my dashboard. If you look closely, there's no more completed transformer inspections in my inbox. Now I can review the pole replacement work order and go through that same process. In this work order, since we're not observing anything, I'm most interested in the cost that's been tracked for budgeting purposes. So I can see all my crew's labor, equipment, material cost has been properly added to the work order. And we can also see the difference between what we estimated that cost to be. And here we got a 21% difference in what was estimated coming from the template level. I can also make sure that my tasks were completed and performed correctly, as well as those attachments, again, were added successfully. So closing the loop on the work order here, as the boss, I've closed the work order. That again is going to fall out of my inbox. And if I scroll down towards the bottom of this, you'll also see my updated KPIs showing that I have now a new pole replaced. So that went from 12 to 13. Our transformers inspected went from 21 to 22, and the cost went up for this total program. Now, to finish up this demonstration, we're going to again go to the app switcher, highlight another HTML5 app within the solution, and move on to our project management application called OpX. Now, within OpX, we can track project budgets for any asset type or group of assets, assign these things a budget, a start date, a finish date, pretty much manage any costs that are being logged into the system. And I have created a project for transformer replacements based on this utility and that inspection program I designed off of operational insights to be assessing these by risk. And we've set a $150,000 budget for this work. Now, within the project itself, I have some basic fields on the left that we're tracking, including the project status, the fiscal year that this is applicable, the start and finish dates, which is just January 1 to December 31st, and then maybe the controller or somebody who is responsible fiscally for this project within the organization. And then we can look at any work activity that has this project code associated with it will get logged here in this repository for cost. So we can go back and look at the work order that was responsible for the bulk of the project cost so far, take a look at it, understand why this costs so much or so little, and then get some insights into how are we doing as a utility against the budget we set forth at the beginning of the year. You'll see in this instance, we've gone over our budget of 150K to an actual spend of 158,000. So, you'd be able to document why we went over budget, how we went over budget, and really have a report ready to justify any expenses over the budget or to budget for more next year. So with that, that's really going to close the loop on this demonstration. We've taken you all the way through a transformer-based risk replacement program. We've inspected that transformer, including its condition in the Unity mobile app in the field, created a work order for a pole replacement and had a crew replace that, and then had the supervisor or asset manager close all these activities in the field, review them, and review the costs within the office. So at this point, I'm going to wrap this up and hand it back to Bill and myself for Q&A.
All right, Gregor, thank you for that great demo showing the different processes and workflows. I think before we dive into a few questions I see are out there, I just wanted to wrap up a little bit and just kind of hit some of the highlights of what we were presenting. It's really wanted to focus on the GIS, leveraging the GIS-centric nature of the applications to leverage your investment in ArcGIS. Wanted to show, and I think Gregor did a great job, how field workers benefit from having disconnected access to that information and the GIS in the field. Showed the cloud infrastructure and how easy it is to deploy in the cloud. That really streamlines your investment costs and the streamline process. And then finally, streamlining those complex workflows into simplified work in the field using a combination of both the office and the mobile apps. I think we had a few questions, Nick, that came in. I think we have a few minutes to try to answer those.
Yeah, we've got a handful of questions in about 6 minutes. So We'll kind of rapid fire through some of these and I'll just toss them out there. Either one of you can answer. If you have any questions, throw them in the Q&A panel. We'll get to as many as we can in a few minutes. First one, what type or types of GNSS tools for areas without cell service does this configuration support?
I can take that one, Bill. If you're talking about actual Trimble GNSS receivers, in most cases, those are using satellite, so we're not having to worry about a cell service connection. They're going to actually use Bluetooth to connect to the platform. But if we're talking about Trimble Unity Mobile, the application itself, again, that was using tile package maps to go offline with your map and your work activities. So as long as you sync for that week or prior before going outside, you can download that data to the device and continue to use a map offline without any cell service.
Following up a little bit on offline, what other offline capabilities does the solution have?
So for offline capabilities, you can capture your XY location in the field. You can continue to work on any work orders, inspections, or service requests that are already assigned and downloaded to that user, as well as view the GIS asset information in the field and take a look at that surrounding base map of your distribution or transmission network.
So one of the big things is, how long is this going to take? So, how does this workflow, what does that time frame kind of look like?
Yeah, I can tackle that. Those jumpstart processes are somewhere in the neighborhood of 3 months. We like to get them up and running and get started. We have other projects that go enterprise and they go a couple of years. It depends on how big a project, how many users, how many workflows, different departments, and what your utility can basically accommodate. So, that jumpstart 3 months. Otherwise, some projects, enterprise projects, can run over a year.
Is this solution a cloud-based, or would this require installation?
It can support both. Right now we see the trend is to go cloud, but we can install this on your infrastructure on-prem. It also supports.
In terms of recording some data, is there the ability to, instead of writing comments, can you actually audio input the comments?
You can, and that's more of a function of the device itself than the software. So if you use the dictation capabilities on your keyboard, either on your device, you can then speak into the microphone, and it's going to use however well your device translates the text, or your voice into text. And then you can save that as a comment. If you've got gloves on, it's extremely cold outside, some circumstance where it's hard to type, that dictation does come in very handy. And again, more of a function of the device, but we will take those capabilities and save them to the forms.
I think we'll probably have to wrap there with questions. But if anyone has more questions, don't hesitate to reach out. I think we have one more slide that has the email addresses for both Bill and Gregor. I think there's one more right there. There's Gregor's email. So if you have any more questions, don't hesitate to reach out to him if we didn't get to it. Real quick, Bill, Gregor, anything else before we close out for the day that you just want to add?
Go ahead.
Just thank everybody for attending this webinar today. Again, there are many topics we didn't touch upon. Hopefully we hit the mark, catering to the bulk of people who are interested in enterprise asset management, but the solution capabilities extend beyond what we were able to show in this short 1 hour webinar. So if you're interested in other topics as well, edge management being big, virtual reality, data collection, things of that nature, please also follow up with us and we can answer to you how the solution can work for your needs.
Right. Yeah, I just like to thank everybody too. And if you have any questions, I know we Power Engineers does a lot of work with the utility network. That might be something that's piqued your interest as we support that product. If you want to reach out, Power Engineers has been working with the utility network for a long time, 5+ years, and we're happy to help. Also want to thank you. I know there's a lot of webinars going on right there. I just appreciate you attending today. Hopefully it was helpful.
Hey, well, Bill, Gregor, great job. Great props for a great presentation. Thanks again, everybody, for joining. These slides will be available along with this presentation in the next handful of days, and it will be automatically sent to you. So just be on the lookout for that. We do have a post-webinar survey, so please fill that out. Once again, if you have any questions, don't hesitate to reach out. And if not, have a great rest of your day, and hopefully we'll connect soon on another webinar.